In this video, we are going to look at parallel vector and a couple of concepts related to it that are very useful. First of all, we had mentioned it before, two non-zero vectors are parallel if and only if one is a scalar multiple of the other. So V is parallel to W if and only if, and let's add the condition here that neither V nor W is the zero vector. Otherwise, this wouldn't make sense. So if and only if there exists some value k, just a real number, such that one of the vectors is k times the other one. In particular, we are going to be interested in looking at when points are collinear, so when points lie on the same straight line. So we will define that A, B, C are collinear if and only if there exists some k such that when we look at AB, this is the same as the vector k times BC. So we are saying if and only if we have that AB and BC are parallel vectors. The other concept related to this that is useful is the concept of what a unit vector is. And this is a vector that has magnitude 1 that we have mentioned before. So this is V such that the magnitude of V is equal to 1. Many times it's useful to find, given a vector A, such that the magnitude of A is not 0, so it's not the zero vector. Then we consider a new vector, let's say A with a tilde, such that this is the vector A multiplied by 1 over the magnitude of A. So this one now is a unit vector. And sometimes it's useful to consider a unit vector in the direction of a given vector. So let's see what we had over here. We wrote down the definition of parallel vectors, of collinear points, a unit vector, and we define a new vector in the direction of a given one, but with magnitude 1. Let's look at an example of how we apply these concepts. So here are our examples. So first we want to find a vector V, which has the opposite direction to a given vector and also has length 5. The first thing that we are going to do is, well, if we write the original vector, let's say I call it W. This is written using the coordinate unit vector, so negative I minus 2j minus 2k. I would like to know what is the length of this vector. And this is given by the square root of 1 plus 2 squared plus 2 squared. So this is 1 plus 4 plus 4, 9, square root of 9, 3. So this is a vector with length 3. The V we are trying to find has to have the opposite direction. So we are going to have to consider minus W. So I plus 2 times J plus 2 times K. And then if we multiply by 1 over 3, we will be making a new vector that has the direction opposite to the original one, and it's a unit vector at the same time because I divided by the length. But I don't want a unit vector, I want a vector with length 5, so let's multiply that by 5. And that's a vector we are looking for. We can also write it as 5 over 3 times I plus 10 over 3 times j plus 10 over 3 times k. A vector with length 5 and opposite direction to the given vector. For our second example, we have the points A, B, and C given, And for the point C, we do not know the y and z coordinates, and we want to find them so that the three vectors are collinear. So I'll begin by writing what the vector from A to B is, the vector AB. I'm just going to use coordinate notation. So 11 minus 2 is the x coordinate, minus 9 minus 3 is the y, and 7 minus 4 is the z. So this is my vector AB with coordinates 9, minus 6, and 3. Okay, this has to be parallel to the vector BC. So let's write what the vector going from B to C looks like. For the x coordinate, we have minus 13, minus 11 for the x. For the y, we have a minus negative 9, and for the z, b minus 7. So this is the vector with coordinates minus 24, a plus 9, and b minus 7. And what we want is AB such that AB is k times BC for some value of k. So let's see how we achieve this. So we are saying that we want 9 to be k times negative 24. So that means we want the value of k to be negative 9 over 24. Can simplify this to negative 3 over 8. We also want negative 6 to be the same as k times a plus 9. So for the value of k that we found, we are saying that we want a negative 6 to be equal to negative 3 over 8 times a plus 9. And from here we want to find the value of a. So let's see here. We can simplify the signs. We can divide by 3 to simplify as well. So we will have that we want 16 to be equal to a plus 9. So we are saying that we want a to be equal to 7. Then for the z coordinate, we want 3 to be the same as k times b minus 7. And since we already found the value of k, this means that we want 3 to be the same as negative 3 over 8 times b minus 7. This means that if we simplify the 3's, we want negative 8 to be the same as b minus 7. So for the value of b, we want negative 1. So we found a and b to make sure that the points A, B, and C are collinear.